Assalamu alaikum. We will speak about EKG analysis technique, which are used in our case of study that we are worked with. Beginning before we diving in the case of study, we'll speak about what is the EKG. EKG methods to interpret the EKG, also known as ECG recordings. It's plots of the electrical activity of the heart rate. EKG analysis can help diagnose various cardiac conditions such as arrhythmia, ischemia, infarction, hypertrophy, and electrolyte disturbances. There are different approaches to EKG analysis, but a common one is to follow a systematic checklist that covers the following aspects: rhythm, B-wave morphology, and BR interval, QRS complex, ST segment, T-wave. First, rhythm. Assess the ventricular and atrial rate and rhythm by measuring the BR and BB intervals. Check if the rhythm is regular or irregular and if there are any ectopic beats or pauses. Identify the B wave and their relationship with the QRS complex. Determine the origin of cardiac impulse and the conduction pathway. Second, B wave morphology and BR interval. Check if the B wave are positive in lead 2 and have a normal shape and duration. Measure the BR interval and check if it is constant within normal range. Look for any signs of atrial enlargement, atrial abnormality, or atrioventricular plaque. Third, QRS complex. Measure QRS duration and check if it is within normal range. Look for any signs of bundle branch plaque, ventricular hypertrophy, ventricular pre-excitation, or ventricular ectopy. Assess the QRS axis and check if it is normal or deviated. Look for any signs of ischemia or infraction by identifying Q wave, ST segment change, or T wave inversion. Fourth, ST segment. Assess the ST segment level and check if it is isoelectrical or deviated. Look for any signs of ischemia, injury, or infraction by identifying ST elevation or depression. Also look for any signs of precardial ventricular aneurysm or electrolyte disturbance by identifying ST concavity or convexity. T-wave. Assess the T-wave morphology and check if it is positive or negative in different leads. Look for any signs of ischemia, infraction, ventricular strain, or electrolyte disturbance by identifying T-wave inversion, flattening, peaking, or notching. Case of study. The goal is to study the effects of drugs on the ECG parameters and rhythm of mice with different cardiac ion channel of protein. The experiments involve implanting telemetered ECG device in live and restrained mice, administering the drugs and recording ECG signals to 2-3 hours at 1000 samples per second. The recording ECG signals need to be processed and analyzed to obtain various measures of interest, such as RR time series, interval measurement, lead potential, arrhythmia detection, and frequency domain analysis. The results need to be visualized and interpreted to compare the ECG pattern of wild type and knockout mice and to evaluate the drug effects on cardiac electrophysiology.
Problem statement. Technical challenges. Handling large and noisy ECG data files that may require segmentation, filtering, denoising, normalization, or standardization. Choosing appropriate methods and parameters for the ECG signal processing and analysis, such as signal averaging, RR analysis, interval measurements, late potential detection, arrhythmia detection, and frequency domain analysis. Validating the accuracy and reliability of ECG signals, processing and analysis methods by comparing them with manual or expert annotations or other reference methods. Visualizing and representing the ECG signal processes and analysis results in a clear and meaningful way. such as plots, tables, graphs, or charts. Interpreting and explaining the ECG signal processing and analysis results in terms of their meaning, such as significance, implications, or limitations. Finally, collaborating with different experts and stakeholders involved in the case of study, such as technicians, cardiologists, electrophysiologists, and researchers. Pre-processing and analysis steps. Pre-processing, signal averaging, PR analysis, and data visualization. Pre-processing. 1. We may need to segment the single large file into smaller segments corresponding to each ECG complex or each time point of interest. 2. We may also need to filter or denoise the easy ECG signals to remove any artifacts or noise that may affect the quality of the signal averaging or PRR analysis. 3. We may also need to normalize or standardize the ECG signals to make them comparable across different experiments or conditions. Signal averaging. We may need to choose an appropriate method and parameters for signal averaging, such as time domain, frequency domain, or wavelength domain signal averaging, and the number of ECG complexes to average, the alignment or fiducial point, the frequency or wavelength to use, and the threshold or criteria to detect the late potentials. We may also need to validate the accuracy and reliability of the signal averaging method by comparing it with manual or expert annotations or other reference methods. Finally, RR analysis. We may need to choose an appropriate method and parameters for RR analysis, such as time domain or frequency domain RR analysis, and the algorithm or criteria to detect the R peaks, the measures or statistics to calculate from the RR intervals, and the frequency bands or ranges to use for frequency domain analysis. We may also need to validate the accuracy and reliability of the RR analysis methods by comparing it with manual or expert annotations or other reference methods. Data visualization. We may need to choose an appropriate way to visualize and represent the results of signal averaging and RR analysis, such as plots, tables, graphs, or charts, and the format, style, color, scale, or labels to use for each element. We may also need to interpret and explain the results in terms of their meaning, significance, implications, or limitations. Problem solution. We think the way of solution is reasonable and practical. Given the constraints and requirements of the case of study, used Excel and Visual Basic to quickly explore and analyze some small sets of data, and then used MATLAB to perform more comprehensive and efficient analysis on the entire dataset. We appreciate the flexibility and creativity in using different tools and methods to solve a problem. MATLAB is a good choice for software based on the criteria: completeness of documentation, ease of use, analysis, display, archiving, ability to handle data files up to 13 million data points in length, user base at this location, ease of transferal of updating and maintenance tasks to others, such as graduate or undergraduate students, cost of one or more licenses as necessary.